This is a review for quiz 6. It covers chapter 6, which is all of the quadratic functions. Number 1, write a quadratic function f in standard form. The zeros of this function are 2 and -4 with a leading coefficient of 3. So we cannot start in standard form. We actually have to start in the factored form. The factored form looks like this: f of x equals a, x minus r1, x minus r2, where a is the leading coefficient and r1 and r2 are the roots of this quadratic function. So we'll fill in the numbers. A is 3, then x minus the first 0 is 2, then x minus the second 0 is -4. I'll go ahead and simplify this a little bit. 3, x minus 2, and then x, the double negative, will become a plus. Now, this is a factored form of the quadratic function. We need to actually put it in a standard form. To do that, you will FOIL the x minus 2 times x plus 4, and then multiply everything by 3. X times x is x squared, x times 4 is plus 4x minus 2 times x, -2x, -2 times 4 is -8. Like terms inside the parenthesis x squared plus 2x minus 8, and then distribute the 3x squared plus 6x minus 24, and that is your quadratic function in a standard form. Number 2 is giving you graphs of quadratic functions, and you need to answer the questions based on those graphs. For each coefficient, a, b, c, d, figure out if it's positive or negative. When the graph opens down, when the parabola points down, it's a negative leading coefficient. When it opens up, it's a positive leading coefficient. So A is negative, B is positive, C is also positive, and D is negative. Part B, which of the coefficients is closest to 0? Now, closest to 0, the smaller the number, the smaller the leading coefficient, the wider the graph. The smaller number will be closer to 0. So this is the widest graph. It does not matter whether it opens up or down here. So for us, it's D. Now this next part, it does matter whether the graph opens up or down. Which coefficient has the least value? Well, the least value means the smallest number. The smallest number means you have to consider the sign. The graphs that are pointing down or opening down have a negative leading coefficient. Negative numbers are always smaller than positive numbers. So in this one, we are looking for the skinniest upside down graph. Which would be part A. Number 3, we're analyzing a graph of the parabola. So first of all, does the parabola open up or down? This one opens up. Find the equation of the axis of symmetry. Well, the axis of symmetry is the line that the parabola is symmetric over. And for us, that is at x equals -2. Equation means that you have to have x equals as part of your answer. Find the intercepts. The x-intercepts, that's where the graph crosses the x-axis. That's here and here. We're going to do them as points. So -6, 0. And there's another one at 2, 0. The y-intercept is where the graph crosses the y-axis. That's right here. They cannot be more than one. And also as a coordinate pair or as a point, 0 on x, -6 on the y. The coordinates of the vertex of the parabola is either a min or a max. The vertex for this graph is right here. The coordinate of the vertex is -2, -8. Let's try it one more time. Does the parabola open up or down? This one also opens up. Find the equation of the axis of symmetry. The axis of symmetry is this dashed line. We don't graph it. It's this dashed line right here, and that's x equals 2. X-intercepts, there's only one, and it is at the same place at 2, so 2, 0. The y-intercept is right here at 0, 4. The coordinates of the vertex is sitting on the x-axis, so it's 2, 0. Use factoring or the extraction of roots to solve these equations. So these are all quadratics, so let's go ahead and look at them. This first one, since it does say it's factoring or extraction of roots, we know that if we have a middle term, we need to use factoring. So let's go ahead and factor this one. Two numbers that multiply to 10 and add to 7. That would be 5 and 2, both are positive. Then zero factor property will give you x plus 2 equals 0, or x plus 5 equals 0. So x equals -2, or x equals -5. The second one, part B, we don't have a middle term. We don't have a number times x. So this one is set up to be done by the extraction of roots. Let's go ahead and add 32 to both sides. 2x squared equals 32. Then divide by 2. X squared equals 32 divided by 2, which means x squared equals 16. Now you can go ahead and take the square root of both sides to get rid of the square on the x. When you're taking the square root of the right-hand side, please don't forget the plus or minus before it. So x equals plus or minus 4. Part C, so this one is the easiest problem in this whole set of problems because it's already factored and it is completely set up to be using the zero factor property. So we have two parentheses that are multiplied together that the product equals 0. So either 3w plus 4 equals 0 or 5 plus w equals 0. So 3w equals -4, which means w equals -4 over 3. That's your first answer. And then subtract 5 from both sides. W equals -5, and that's your second answer. Part E, we have a quadratic, but it's not written in standard form. In order to solve it, we have to write it in standard form. So let's move everything to the left-hand side. 5x squared minus 17x plus 6 equals 0. Then we will go ahead and factor it. I am partial to slide and divide when I'm doing factoring when there's a number in front of the x squared, so that's what I'm going to do here. In order to use the slide and divide, we first multiply the first number by the last number, and then we rewrite that equation without the 5 in front of the x squared minus 17x plus 30 equals 0. Then we go ahead and solve as if there was no number in front of x squared. So x and x, two numbers that multiply to 30 and add to -17. That would be 15 and 2, and both of them have to be negative. Now, at this point, you have to divide. Since we multiplied by 5 in the beginning, we have to divide both of these numbers by 5. The first parenthesis will just give you a whole number. So it will be x minus 3. The second parenthesis, since 2 over 5 is not a whole number, we will tuck in the 5 in front of the x. So now this quadratic equation is factored, and then you can use the zero factor property to say x minus 3 equals 0 and 5x minus 2 equals 0. So x equals 3, that's the first answer, or x equals 2 over 5, and that is the second answer. Part D, once again, we have a quadratic that's not in standard form, so go ahead and put it in standard form. Y squared minus 13y plus 30 equals 0. We'll go ahead and factor this out. Once again, two numbers that multiply to 30, but this time they add to negative 13. It's still 15 and 2, but this time 15 is negative, but 2 is positive. So y plus 2 equals 0, y minus 15 equals 0. So y is negative 2, or y is 15. Part F does not have a middle term, so it does not have a number times t, so this one is set up to be done with the extraction of roots. Go ahead and add 75 to both sides. 3t squared equals 75. Divide by 3 to isolate t squared on the left-hand side. 75 divided by 3 is 25. Then take the square root of both sides to get the t value. Square root and square cancel each other out. T equals plus or minus 5. Number 5, we're rewriting the quadratic function that's written in the vertex form in the standard form. So let's go ahead and do that. F of x equals 3. X minus 4 squared minus 2. You will have to square the x minus 4 first. If you don't remember how to do that, you can expand it as x minus 4 times x minus 4. That's what a square means. Then go ahead and FOIL it to get the answer. X squared minus 4x minus another 4x plus 16 minus 2. 3x squared, like terms in the middle, minus 8x plus 16 minus 2. We still have to distribute the 3 and then do one more set of like terms. So this is 3x squared minus 24x plus 48 minus 2, and 3x squared minus 24x, and then 48 minus 2 is 46. And that is your function in standard form. Number 6 is a word problem. We have an area of a rectangle that's 27 squared feet, and the length is 3 feet less than double the width. Find the dimensions of the rectangle. Please do not guess on these problems. You need to make a quadratic equation, or in this case, a system of quadratic equations, and then solve. All the work should be shown. So we'll start with the area. W times L, so width times length is your area formula. So for us, plugging in the actual values, W times L equals 27. Now we also know that the length is 3 feet less than double the width, so L equals 2W minus 3. This is a system of equations. It's set up to be done by a substitution technique. So you will take this expression for L, and you're going to plug it into the first equation. So the first equation will become W times 2W minus 3 equals 27. So 2W squared minus 3W equals 27. It's a quadratic, so put it in standard form. 2W squared minus 3W plus 27 equals 0. I'm just going to use the guess and check technique here. So we need two numbers that multiply to 27, or negative 27. This one is negative. Okay, it's two numbers that multiply to negative 27 and add to negative 3. We don't have that many possibilities. It has to be 3 and 9 here. minus and plus. It's called guess and check because you now have to check to make sure that you got what you want. 2w times w is 2w squared. 2w times 3 is 6w. Negative 9 times w is negative 9w. Negative 9w plus 6w is negative 3w. And then, of course, negative 9 times 3 is negative 27, so it works out fine. Zero factor property, 2w minus 9 equals 0, or w plus 3 equals 0. So 2w equals 9, which means w equals 9 over 2. Generally, we would leave our solution as a fraction, but since it is a word problem, it is more meaningful if we turn it into a decimal, 4.5 feet. It means more to us whenever we look at it. So the width is 4.5 feet. Now, w equals negative 3 does not make any sense. We cannot have negative width. So we'll just ignore it. We don't need to do anything with it. So our width is 4.5 feet. We still need to find the length. So let's go back to this formula right here, or this equation. So L equals 2. Instead of W, I'll plug in 4.5 and then minus 3. So 2 times 4.5, that's 9, minus 3 is 6 feet. So the length is 6 feet. The width is 4.5 feet. Number 7, we need to determine whether the parabola has a maximum or a minimum, and then the maximum minimum value, and where does it occur. So max or min is determined by the leading coefficient of the parabola. This leading coefficient is negative, which means the parabola will open down, so that creates a maximum. What is the function's minimum or maximum value? That is the y-coordinate of the vertex. We cannot find the y-coordinate until we find the x-coordinate. So part C says at what value of x does the minimum or maximum value occur? So this is the x-coordinate of the vertex. We can find that one. So x-coordinate of the vertex has a formula, minus b over 2a. So for us, that would be minus 28 divided by 2 times negative 2. So that's positive 28 over 4. Since it's a double negative, it's going to be positive, and that would be 7. So the maximum value will occur at x equals 7. What is the minimum or maximum value? That is the function value at 7. So you take that number that you found in part C and plug it into the original function. So that's negative 2 times 7 squared plus 28 times 7 plus 1. And if you calculate it out, you should get 99 as your maximum value. Number 8 is another applied problem. A ball is launched vertically upward with an initial velocity of 72 feet per second. The ball's height is given by the following equation. After how long will the ball reach its maximum height? So once again, we are trying to figure out what we're looking for. So if you quickly picture this problem, this is time and this is height. This particular equation can be rewritten in more standard form, negative 16t squared plus 72t. We don't have a c on this quadratic equation. So since the leading coefficient is negative, the parabola is going to open down, which means the vertex is going to create a maximum, and that would be your maximum height. Well, it's not asking us to find the maximum height. It's asking us how long will it take to reach the maximum height. So we need this time right here. So t to maximum height is the t coordinate of the vertex, so minus b over 2a. Since we've rewritten our quadratic in a standard form, we know that b is 72, so minus 72 divided by 2 times negative 16. So that's 72 divided by 32, and that should give you 2.25 seconds. Do not round these calculations. It is important that you include every decimal here. Number 9, we are finding the vertex, axis of symmetry, x-intercepts, y-intercepts, maximum, minimum, and then also graphing the parabola. So lots of things in one question. We'll start by finding the vertex of that parabola. The x-coordinate of the vertex, minus b over 2a. So that's minus a minus 4 over 2 times negative 1. So that's positive 4 over negative 2, which is negative 2. The y-coordinate of the vertex is the function value at negative 2. So negative 2 squared minus 4 times negative 2 plus 5. If you calculate it out, you should get 9. So the vertex would have a coordinate of negative 2, 9. We can go ahead and plot it right away. Negative 2 and 9. There it is right here. Okay, axis of symmetry. Now, axis of symmetry always runs through the x-coordinate of the vertex. So it's going to be right here. No calculations needed here. It needs to be an equation, x equals negative 2. X-intercepts and y-intercepts. Go ahead and go down below to calculate the x-intercepts first. So the x-intercepts happen when y is 0. So we have negative x squared minus 4x plus 5 equals 0. Now have a negative in front of x squared, so I'm going to multiply everything by negative 1 to get rid of that negative. You couldn't do it before. You can only do that when you set the y equal to 0. Otherwise, it's not a legal mathematical operation. So x squared plus 4x minus 5 equals 0. Factor. 5 and 1, they have to multiply to negative 5 and add to positive 4. So plus and minus, so x equals 1, x equals negative 5. We can go ahead and plot those two. I'll go ahead and put them down first. So 1, 0, and negative 5, 0. That is right here and right here. Now the y-intercept. The y-intercept is actually easier than the x-intercept. This happens when x is 0. So all you have to do is just plug in zeros for x's. So minus 0 squared minus 4 times 0 plus 5. So if you just ignore the zeros, it's just 5. So 0, 5. And that would be right here. Now, because that's not 5, that's 3. And that would be right here. Now, because of the axis of symmetry, you can actually have another point. So this point is 2 away from the axis of symmetry. So there's another point 2 away to the left of the axis of symmetry. Now we have enough points to graph this parabola, so we'll go ahead and do that. And then we'll answer the last question, which is whether the parabola has a maximum or a minimum and giving the value of it. This parabola has a maximum value and it is at the vertex, so negative 2 and 9. This is an acceptable answer. Sometimes because it says give value, it really just wants the y coordinate of this vertex, which is 9. I would accept both answers in my class. Number 10, another applied problem. A vehicle factory manufactures cars. The unit cost C depends on the number of cars that are made. So we need to figure out if X cars are made, then the unit cost is given by this function. We need to figure out what the minimum cost is. So on this one, if you want to picture it, this is X and this is C. Since the leading coefficient is positive, the parabola will actually open up here, creating a minimum. So this would be your minimum cost, but we can't find it until we find how many units we need to produce to get to that minimum cost. And the units are measured in X coordinate of the vertex. So we have to find the X coordinate of the vertex first, minus B over 2A. That's minus a negative 150 over 2 times 0.5. So that's just positive 150, and it's cars. Do not box it in. That is not an answer to this problem. This is just an intermediate result that we need to calculate the actual minimum cost. The minimum cost is just the function value at 150 cars. So that's 0.5 times 150 squared minus 150 times another 150 plus 18,722. If you calculate it all out, you should get $7,472, and this is the minimum cost. That is the final answer. You can box that one in. Another analysis of the graph. So same thing, find vertex, axis of symmetry, x-intercepts, y-intercepts, and maximum and minimum. We always start with a vertex. So x coordinate of the vertex minus b over 2a. So that's minus a minus 6 over 2 times 1. So that's a positive 3. And then the y coordinate of the vertex, plug in that 3 into the equation, 3 squared minus 6 times 3 plus 5. That should give you negative 4. So the vertex is at 3, negative 4. We'll go ahead and plot that point. 3 and negative 4, that's right here. Then the axis of symmetry always runs through the x coordinate of the vertex, so it's going to be at x equals 3. The x-intercepts and the y-intercepts. The x-intercepts, so that's y equals 0. So that's x squared minus 6x plus 5 equals 0. Factor. Two numbers that multiply to 5 and add to negative 6. That's 5 and 1, and we have both of them have to be negative to actually add to negative 6. So x equals 1 or x equals 5. We'll go ahead and plot those. 1 and 5 and write them down as coordinate pairs. So 1, 0 and 5, 0. Go ahead and do the y-intercept now. That's when x is 0, so 0 squared minus 6 times 0 plus 5, and it is at 5 again. So 0, 5. Another point that we can do is the one that's symmetrical to this orange point right here. This point is 3 away from the axis of symmetry, so 3 away on the right-hand side will be another point. So we have enough information to actually graph the parabola. And then max and min question. This parabola creates a min, and the value is the y value, -4. Or if you want to put the point, that's okay also, 3, -4. One more applied problem. A model rocket is launched with the initial upward velocity of 113 feet per second. The rocket's height after t seconds is given by the following function. Find all values of t for which the rocket's height is 39 feet. And we're going to be rounding to the nearest hundredth, which is 2 decimal points. So on this one, h equals 39, and we need to find the time that it takes to get to 39. So we'll have to plug in 39 for h, and then solve this equation for t. So this is a quadratic, so it needs to be in the standard form. I do not have it in the standard form currently. So we'll go ahead and move everything to the left-hand side. So this is 16t squared minus 113t plus 39 equals 0. Now that it is in standard form, I can go ahead and solve it. Now this one is probably not factorable, so we'll go ahead and utilize the quadratic formula here. Just in case you forgot the quadratic formula, x equals minus b plus or minus square root b squared minus 4ac, all that divided by 2a. So t equals minus b, so that's minus a minus 113 plus or minus square root negative 113 squared minus 4 times 16 times 39. Divided by 2 times 16. So t equals 113, double negative becomes a plus or minus square root. If you calculate everything underneath the square root, that's 10,273, and it's divided by 32. At this point, I'm going to split it up into two equations. So t1 would be 113 minus the square root of 10,273 divided by 32. And t2 will be 113 plus the square root of 10,273 divided by 32. Putting it into a calculator, you should get 0.36 seconds as your first answer and 6.70 seconds as your second answer. I am rounding them to the 2 decimal points. More quadratic formula questions. And in this one, we have to give exact, fully simplified answers. So no decimals are allowed as your final answer. We'll go ahead and start with this one. 9x squared minus x minus 2. So x equals minus b, so that's minus a minus 1, plus or minus square root of -1 squared minus 4 times 9 times -2. Divided by 2 times 9. Double negative in front of the 1, that's 1 with a plus sign, plus or minus square root. Calculating everything underneath the square root, you should get 73. And then divided by 18. Now, square root of 73 is not simplifiable. You cannot make it any simpler than that. So this is as far as you can go on this question. Let's try part B. We have x equals minus b, so -8 plus or minus square root 8 squared minus 4 times 6 times 1 divided by 2 times 6. So it's -8 plus or minus square root of 40 divided by 12. Now, 40 is something that we can simplify when it is a square root. So let's go ahead and do that. -8 plus or minus square root. 40 is 4 times 10. Square root of 4 is 2. Square root of 10 stays under the radical. Now, to further simplify this fraction, you can do a couple of things. You can factor the greatest common factor on the top and then reduce it with a 12, or you can split it into two fractions. So -8 divided by 12 plus or minus 2 square roots of 10 divided by 12. And now you can reduce each fraction individually. So -8 over 12 is negative, we're reducing by 4 here, -2 over 3 plus or minus, and then 2 and 12 will also be reduced. So that's just 10, and then 12 divided by 2 is 6. And this is as far as you can go with simplification. Part C, this quadratic is not in standard form, so in order to actually do this, you have to first put it in standard form. So 9x squared minus 4x minus 2 equals 0. X equals minus a minus 4 plus or minus square root of -4 squared minus 4 times 9 times -2 divided by 2 times 9. Double negative before the 4, that's a positive 4 plus or minus. Calculate everything underneath the radical, that's 88 divided by 18. 88 can also be simplified further. This is 4 plus or minus square root of 4 times 22 divided by 18. So this is 4 plus or minus square root of 4 is 2. Square root of 22 stays unchanged over 18. Split it into two fractions, 4 over 18 plus or minus 2 square roots of 22 over 18. Reduce the 4 and the 18 by 2. This is 2 over 9 plus or minus. Reduce the 2 and the 18 the same way. This is the square root of 22 divided by 9. This is as far as we can go in the simplification process. And this last one in this set, that's also not in the standard form. So let's go ahead and put it in the standard form. 7x squared minus 3x minus 2 equals 0. Then do the quadratic formula. X equals minus a minus 3 plus or minus square root -3 squared minus 4 times 7 times -2 divided by 2 times 7. So double negative in front of the 3, 3 plus or minus square root. Calculate everything under the radical. You should get 65 divided by 14. Now square root of 65 cannot be simplified any further, so this is your final answer. And the last question, we need to graph the parabola that's written in the vertex form. So the easiest way to do that is to first figure out the vertex. The vertex form of the parabola has this general equation, a, which is your leading coefficient, then x minus h plus k, where the vertex is at the point hk. So if we're working with our function, switch color here. If I rewrite our function, y equals 2, that's my leading coefficient, then x minus, that's part of the formula, then minus 4, that's the h, and then minus 2, which is the k. So then the vertex would be at -4, -2. I'll go ahead and plot that. -4, -2, that's right here. Now, once you figured out the vertex, you can start your calculations. My vertex is at -4 on the x. One step to the right from -4 is -3. So the next x that I'm going to deal with is x equals -3. We need to find y. So y equals 2, -3 plus 4 squared minus 2. That's 2 times 1 squared minus 2. That's a 0. So -3, 0, that's this point right here. Now, you know that by the symmetry of this parabola, I'll go ahead and graph the axis of symmetry here. You know that by the symmetry of the parabola, there should be another point that's symmetrical on the other side. Now, I'm going to go ahead and do the last one that we need to calculate. So from this point has the x coordinate of -3. Go one more to the right, that's -2. So x equals -2 is what we're going to calculate next. So y equals 2 times -2 plus 4 squared minus 2. So that's 2 times 2 squared minus 2. That's 8 minus 2, which is 6. So we're going to plot -2, 6 as our point. So -2 and all the way to 6. And you know that by symmetry of the parabolas, we would have another point 2 away from the axis of symmetry on the other side. So this is enough points to actually connect the dots and graph the parabola itself.